How are you, my friends? This is Calculus 1 solved questions about continuity and discontinuity. Question number 1, we start with a nice question. Find the points where the function is discontinuous and name their types. So look at the function f of x. This is a rational function. This is a rational function. So we can factor up and down to check if there is any hole in the graph. So we leave this x minus 2. In the factoring down here, we put x minus 1, x minus 2. See, when you multiply here, you get this one. So you cancel x minus 2. That means x cannot be 2 in that case. So the function becomes 1 over x minus 1, which is a rational function also. See, this is a rational function, vertical asymptotes at 1, and x cannot be 2, so there is a hole here at 2. Now let's discuss the discontinuity. The function is discontinuous at 2. See, there's a hole here, but this type is removable. We can remove it. If we redefine the function, we will see another example now. F is discontinuous also at 1. See, it will make here the denominator 0. See, there's a vertical asymptote here. So this function f is discontinuous at x equals 1 also. We call it infinite discontinuity. This is not removable. We cannot find a solution for that, but we can find a solution for this. Now, question number 2, find the interval or intervals where the function, this big function f of x, is continuous. So we have to study this whole function. This is the function f. Let's take the function inside and call it r. This is a rational function here. X minus 7 over x squared plus 2x plus 2. X minus 7, we leave it. Now let's just work here a little. X squared plus 2x plus 2 here. On the right side, you can see what I did. You can split this 2 into 1 and 1. That means I'm completing the square actually here. You can complete the square any way you like. X squared plus 2x plus 1. I leave this one. Now this is perfect or complete. So it's x plus 1 all squared. Now what do we see here? In the denominator, it cannot be 0. So this rational function is defined and continuous everywhere. The denominator here cannot be 0. Now the cube root also, this is to the power 2 over 3. That means we can write the function f r of x to the power 2 over 3, which is cube root of r of x squared. That's the same as the given function. So the cube root function also is continuous. So this is a composition now. So this function is continuous on the whole real line. Question number 3, redefine the function h of x sine of x over x if x is not equal to 0. H of x is equal to 0 if x is equal to 0, so that it is continuous at x equal 0. Now we know the graph of sine x over x. It is not continuous at 0. But the question says redefine it. So what do we do? To redefine it so that it is continuous, we can write the function like this. H of x sine of x over x if x is not 0. H of x is 1 if x is 0. So instead of having 0 here, h of 0 is 0. See, it was here, the point, and there is a hole here in the graph, if you remember. That was not continuous, removable discontinuity. Now we can remove it. We can redefine the function. Remember, redefining the function. So I can write h of x 1. So the function is 1. So we can remove this if x is equal to 0. So now we have this graph continuous everywhere. Let's find the value of m so that this function f of x, m minus x cubed if x is less than or equal to pi, m cosine of x if x greater than pi is continuous for all values of x. we need value here, one value number of m, so that this function is continuous everywhere. Now, if we look at the function here, m minus x cubed if x is less than pi. This is a polynomial function that's continuous everywhere. If x is greater than pi, it's a cosine function. Also, the cosine is continuous everywhere. So we have to check the continuity at x equals pi. To be continuous at x equals pi, we require the limit is equal to the image. That's the continuity definition. Now, for the limit to exist, it should be equal from both sides. So we say the limit of the function as x goes to pi from the left is equal to the limit of the function as x goes to pi from the right. So from the left now, we put pi here, so it's m minus pi cubed instead of this x. On the right side, we put m cosine of the pi. So we have an equation now. We can find the value for the m. So m minus pi cubed. Cosine of the pi is minus 1, so that's minus m. Take it on the other side, becomes 2m, and take this one on this side, becomes pi cubed. So m equals pi cubed divided by 2. That's a constant. It's a number here. Pi cubed divided by 2. This is the value for m that will make this function f continuous everywhere. Now, for more questions on continuity, you can see the Calculus 1 lectures, lecture number 5. For more questions on Calculus 1 in general, you can visit the playlist Calculus 1 Solved Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.